I'm Joe Szodfridt, and these are my colleagues Sean Anderson and Rohit Kelapure. Thank you. All right, today our talk is about tools to slay the fire-breathing monoliths in your enterprise. So everyone knows the benefits of cloud-native architecture. They have scaling on demand. We have more resilient systems. We have increased speed to market, just to name a few. We have lots of resources on how to build these types of systems. We have books, we got blogs, we got conferences just like this. Lots of resources available on how to create good systems. But what do you do about existing apps? You know the ones that actually run your business. They're business critical, they're your systems of record, they generate money for your business. You depend on them day in, day out. What do you do with those? Enter the dragon. Although it's not always these fluffy, happy, smiley dragons, sometimes these are more often big, nasty monoliths that are a little more scary dragons. So how do you take that scary dragon monolith and move it towards a more cloud-native architecture? You need code, but in addition to that, you need process and some methodology tools. So Rohit, Sean, and I have been working on developing these tools to take that dragon and make it a little more happy dragon. This is the input that we're going to present to you from a lot of work with people I see out here from our team as well. We all work for Pivotal. We work on the app transformation team. We call ourselves AppTX, and we're transforming where the world runs their software. We've been doing this for about 3 years. We've had about 45 engagements transforming applications for our customers, and we've collected over 600 transformation recipes that we store in our internal repository to help customers like you transform the world. We do this for a lot of companies that have been here speaking today about our successes, and we appreciate that as well. So today we're going to take you through our dragon-slaying transformation circle here and talk about these tools that we've developed. We're going to talk about OKRs. We're going to talk about event storming, Boris. These names are all recognizable, right? Everybody knows who Boris is. These are slice analysis. We got Snappy and Snap. And of course, we have implementation patterns. And all these tools that we do are always building working code, slices of incremental functionality that we add on to build larger systems and develop reusable patterns that we could use in the future for other engagements. Okay, and again, just to reemphasize, this is a wheel. This is rinse and repeat. We do this around and around all the time. We don't just do this event storming or Boris once and then put it away. We reach for these tools and processes whenever we need them, and we do them just until it's good enough to inform the decisions that we need, and we pull them out again whenever we need them in the future. Okay, so first stop up on our dragon-slaying transformation wheel is OKRs. So imagine you're riding the AppTX bus with us, and you need a place to go. There's lots of places to go. You can go left, right, you can go down. What your decision is or why you want to go there are your objectives. That's pretty straightforward. That's the O in OKR. But on this bus, there's always somebody in the back who's saying, are we there yet? But really, the important question is, are we on the right road? How do we know we're going the right way? So KR, key results, helps you identify whether you're on the right road and you're making it towards your objectives. When we set our objectives for our transformation engagements, we like to make them very ambitious. We like to do a little bit more than we're comfortable with doing. We're always trying to improve. We're always trying to push ahead. The key results need to be numbers. So if you really want to know if you're getting there the right way, you have to have something you can measure. So the key results are metrics that are numbers, decrease, increase, percentage. And what we found from our practice is that these are really hard to come up with. They're hard to come up with good things to measure to verify that you're actually moving towards your objectives. It puts your objectives in a very different light. It makes you think about them very differently. So it is a very good exercise to solidify your objectives as well as to think about how you're making sure that you're on the right path. So if our objectives are ambitious and our metrics are numeric, then we can obviously do some calculation percentage-wise to see how we're doing on those. If your objectives are ambitious and you hit 70–80% of your KRs, we assume that that's good enough. We use that word a lot, right? You don't have to be 100%, you just have to be good enough. If you are hitting 100% on your objectives, either you're really great or you set the bar kind of low. In our experiences, we set the bar too low if we're hitting 100%. So we're always trying to hit 70–80% to make sure that we're hitting those stretch goals. So here's some samples of some OKRs that we had. I kind of mix them together from different engagements, so it's not very recognizable to a lot of people. But they roll up to a higher mission. So in this example here, the mission was to reduce the time to onboard new customers. So we came up with a few objectives to help with that. We wanted to incrementally handle production traffic. We wanted to configure the customer test environment quicker. And you notice that on the very end here, we have an objective that says create guidance for app transformation. So as part of our practice as well, we want to enable people. We don't want to just move applications. We want to enable customers, and we want to help them to develop their own abilities to do this. So generally, in all of our engagements, we usually have one objective that deals with creating some type of enablement knowledge that we can leave behind for you all. And you can see the key metrics that we have here. They're all numbers, right? 1 central cookbook, 5 guidelines, reduced manual steps, 25%, 1 process state migrated to PCF, 1 transition from PCF to legacy. That's a really good one. Those KRs right there, the first column, are really key because that shows the way that we like to work with these monoliths about incrementally moving things into production, but being able to coexist with what exists in the legacy or existing systems. All right, so once you have your objectives, how do we go about identifying these objectives? Okay, so we do 2 things. We got objectives and key results. For objectives, what we do is we get the right people in the room, and with simple tools, we get stickies and we ask people to brainstorm their objectives. They put them up on the board, they put them all over the place, and then we go around and we look at these objectives and we group them together. So we try to find the ones that are similar. Everything that's kind of related, we put in one pile, and we end up with a bunch of piles on this board of things that are potential objective candidates. Then we go through and we write a statement for those objectives that categorizes that pile of work. So these become the goals, the objectives, the directions, the place where that app TX bus is going. So once we have the objectives, we need to come up with the key results. So for key results, for each objective, we create a sheet of paper. It has 2 columns, the could measure and the should measure side. Could is where we brainstorm, and should is where we decide. So on the left, we ask people to brainstorm what could be a key metric. What are the things that you could measure to see if you're on the right path and staying on the right path? Once we have a big pile, then we take a small group of people and we decide which one of those brainstormed key metrics are the things that we should measure. A lot of times we end up with more than 3. We have 3, 5, 7. So what we do there is we stack rank them in order of importance so we can come up with like 3, right? A good objective has 3 to 4 key results. So if you have your key results, we said that we're using OKRs to see if we're on the right road. How do you know if you're on the right road? You have to have some kind of dashboard that reflects your current state and that you can use to radiate the information that you're on the right path or if you need to change. We do this a bunch of different ways. We started doing it in spreadsheets. We still do it this way because some customers don't allow some of the tools that we use, like the military, for example. Spreadsheet is nice. It is a little difficult to maintain, and it's a spreadsheet, right? It's like death by spreadsheet. So I'm not a big fan of this method, but it is useful. We've switched over to using a Trello board, a Kanban board, to do our objectives here. And if you notice, I had some arrows there for the confidence factor. What we added to this system of OKRs is a flag that we use to indicate how confident we are that we're actually hitting that key result. And the reason we did that is because we want these dashboards to quickly radiate the information of whether we're on the right track or we're not, where the trouble spots are. The trouble spots are the key results that aren't being achieved. So what happens is some of these key results are fairly easy to achieve. We're very confident we're going to achieve those, but they end up in that column on the right that says not achieved. And then we have to filter through that to see if these are real problems or if they're just not done yet. So we came up with this confidence factor, and we add the confidence factor, which is a little bit of subjectivity in what's supposed to be an objective thing, so we could filter those into the other columns to keep the column on the right to be the problem areas or the areas that need to make decisions on. There's another way we do this as well. You see we flipped it around here. Before we had the columns in that Kanban board were by status of each objective. This, we have each objective in its own column, and the key results are the cards underneath. This is a better method, in my opinion, for a couple of reasons. One is it shows all the key results, and it shows you which ones are being achieved and which ones aren't. And it also forces you to slim down the objectives you have. From our experience, what we've been doing is when we come up with 5 to 7 objectives, that's a lot of objectives. We work in very short cycles, 6 to 10 week cycles. Having 5 or 7 objectives for 6 to 10 weeks is a lot of objectives. So if you have 2 or 3 for a 6 to 10 week period, that's a really good number. And it forces you to think different about your objectives, and it forces you to think different about your key results. So this is our preferred method at this point in time. And you can also see that we've added some stuff to here. On the side, we use the Trello board actually to go through our midpoint and final reviews where we talk about the things that we learned, the challenges we have, the things that we need to do. So it's kind of everything's in one place. It radiates information really well, and it's super easy to maintain. Okay, so next stop on the dragon slaying transformation. What do we call this thing? The transformation circle, right? I keep forgetting that. Okay.
Circle of transformation.
Circle of transformation.
With a theme song.
We're going to get a theme song to this too, but maybe next year. So the next stop is event storming. All right. So what is event storming? Event storming is a process to build a domain model for your business application using very simple tools. Okay. The simple tools are all those people standing up top. That's a bad joke, but nobody got that. Okay. So anyway, so you have to have a lot of people. We need business people. We're trying to build a domain model. So the domain model means business, right? So we want to know how the business works, what is in this application. Stickies, markers, giant sheets of paper. We like simple tools at Pivotal. So the way we do the domain model is we get all these people in the room. We put a giant sheet of paper on the wall. We give them all stickies and Sharpies, and then we ask them to talk through the system events, the business events, the things that happen in their system, and just put them down along a straight line. Happy case first. So that's pretty easy. We get a bunch of events. That's like the happy path. We like to write those in past tense, the events. So for example, we have like seat chosen, tickets purchased. It just shows that something happened. An event is something that happened, so we like to use past tense in that. Then we start iterating on this model, and we add additional events. So we ask people, okay, well, after the happy path, what happens next? What are kind of like the edge cases? What are the alternatives? And then this model starts to grow. As it grows, you can see we're getting like clumps of things. And the purpose of event storming is to give you a visualization of your application, right? So now we can see that there's clumps happening around here. So we're getting some kind of visual impact from the event storm. So that gives us an indication that some of these things are business context, bounded context. We look at these groups of objects or these groups of events, and we say that the ones on the left, for example, are related to seats. So we'll say that's a pile of bounded context that relates to seats. And the one on the right is about payments. And you can notice that there's a little transition. There's two events between those two big bounded contexts. We see this a lot. When we're looking for bounded contexts, what we see is that there's a lot of activity happening somewhere, and then there's one or two events, and then a whole bunch of other activities happen. That's a signal or visual indication that these are transitions between two larger parts of a system. Okay? Then we iterate on this a little more, and we could add aggregates around these smaller clumps of events. And an aggregate, you can think of that as the brains. So that's something that's making a decision. It's a process. Commands are coming in, and that aggregate is deciding on which events it should generate. So we identify those because those are great candidates for microservices or areas to break down a large monolith. The next thing we do is we mentioned we always work iteratively, so we can't take this giant monolith and rewrite the whole thing. We want to keep it alive, change the jet engine while it's flying, so to speak. So we look for slices. And a slice for us is a series of events. Okay? We want a small section of events that are related that we're going to start with to transform or migrate or do whatever with, right? The slices they can cross aggregates, they can cross bounded contexts. We're not limited to, okay, we're just to transform this, we're just going to write one microservice. We could write 3 microservices here that do nothing but handle one single event to create this event slice. And you can continue to embellish this model. You can add question marks, you can add trouble spots, you can add the commands that you want to. You iterate on this until it's good enough, right? And good enough is different in different contexts. You have to decide when you have enough information from this model to get the answer that you're looking for. So why do we do event storming? Well, first, you need to make sense of a huge mess. Now, I'm not saying your enterprise software applications are a giant mess, but when we come in and say, hey, can you guys help us transform this? And you say, here's 1.5 million lines of code and outdated documentation. From our perspective, that's kind of a mess. That doesn't get us anywhere very quickly. So we need a very rapid way to understand what your system does and to be able to make a decision on where to start. So it helps us make sense of the mess and helps us reveal those contexts, those big areas in that system. It also helps us to identify those slices. It's very important. Remember, we work very incrementally. You can't lift and shift giant things all the time. You have to look for pieces of little threads to pull on to start with. And you need to know what are the real domains, right? The event storm is a business domain modeling tool, so we want to know what those business domains are so we can speak your language and we can build the software to support the business context that you're using. Explore core domains. We're looking at, we want the key pieces, right? We want to know where the trouble spots are, where we need to start with, all those things that we showed you in the model before. We want to know those so either we address the trouble spots or avoid the trouble spots. Sometimes the best place to start is where there's trouble. Sometimes the worst place to start is where there's trouble. And most importantly, on the bottom two are conversation. So when we do these event storms, there's lots of people in the room. Sometimes we have 30, 40, 50 people doing this at a time. And the conversations that happen between those people is more important than the stickies that are getting put up on the board. We walk around and we listen to these conversations, and it rapidly transfers information to us so we can get started. We've also had scenarios where the people who've been in that room have never been in the same room together or only do it like once every 2 or 3 years, which is really impressive. So the conversation aspect of this technique is fantastic. And again, we use it mainly for identifying starting points, right? You always have to know, you have to start somewhere. And when someone gives you a big 1.5 million line application, you can't just say, I'm going to start there. We need to make an intelligent decision on where to start, and that's what we use this tool for. So this picture was in the keynote the other day, so thank you very much for Liberty Mutual for giving us a really good shout out there. And this is actually this is that 1.5 million line application that we event stormed. Rohit is there, I'm there, there's some other pivots there. I see Dan Fry's shiny head, Salman Malik's over there. And then I see Liberty Mutual people there as well. They're sitting here in the audience, so thank you. And we've also done this elsewhere too, so don't think that's the only picture we have of this. We really do actually do this. That picture's been around a real long time. It's a great picture, I love it, but we do this in other places. So here's some other samples of where we've done it. Here's a smaller one. And you can see that we don't use yellow stickies. We don't always use orange stickies. Sometimes we use yellow. Sometimes we use tape. Sometimes we just draw it on a whiteboard. Sometimes we use markers. It's a very versatile tool, and we do this a lot. Okay, so now that we've had our event storming, we have an understanding of what kind of the system looks like, what the domains are. Then we take it to the next level, and then we start looking into architecture. So what we do there, the next tool is Boris, and for Boris, we'll talk. Sean, I'll hand it over to Sean.
All right. So, and you, within the next 10 minutes, we will understand why it's called Boris. And I forgot to bring a prize, but if anybody guesses, you'll get 2 thumbs up at least. So, like everything that we start with, there's more tools, and we're fans of architecture by arts and craft, partially because it gets people out from in front of their computers, and you don't have one person who is the Visio king or queen that is doing all of the diagramming and thus informing your decisions. So in this case, we're going to start again up on a board, but what we're trying to do now is drill down a little bit more into what we learned from the event storming. So as an engineer, I'm looking at, okay, here's the results of my event storm. I understand the business process a little bit better. We're speaking the same language, meaning technical and non-technical, which is key to that. But we don't necessarily know how I'm going to start writing software. And so the goal of the Boris exercise is to start with candidate services. From what Joe talked about, you can see that from those aggregates and those clusters, we could see, you know what, something like a payment service is kind of falling out. And again, usually these are existing systems that we're trying to understand. And so by going through the process of starting with services, we may then start talk about messaging, queues, things like that. Again, we talked about the business events. Often they translate to a real world technical event. A seat was selected or payment requested, something like that. And then there may be a UI aspect to this that as back-end developers, often we don't think about UIs, but maybe there's something that we want to keep track of with that. And then, of course, with any system, especially monoliths, there's always external systems that we have to deal with. And it would be nice to be able to build our software without considering that, but unfortunately, we don't get that choice. So what we'll do with this exercise is we'll start with just talking about what are our potential services. And again, these are just sticky notes. And the smaller team will go through and say, you know what, we have a payment service, this kind of fits, or we have a service that maybe talks about how we're figuring out the seeds. It's really not that important. Again, we're looking for just enough to get started. And some of these services may be really just wrappers around our external services. There's some bad words that people hear like CICS and mainframe, things like that. Those can be external services that we really shouldn't be afraid of. They're just services to us. And then we also can start thinking about, hey, if we're event sourcing or some of the neat distributed computing techniques you heard about earlier today, if we want to start using Kafka queues or even just other kind of asynchronous messaging, let's start throwing up some queues that we'll consider. And once we start doing that, the idea is just to iterate through and say, let's look at a couple scenarios. For example, a customer orders a concert ticket. What are the activities that have to happen here? Well, the first service may put a message on a queue, and then it's going to talk to another queue, and the output goes here. You just talk through those kind of scenarios, and then we'll start thinking about the directions. Oh, okay, now we see this flow. And what ends up happening here as we go through this is we identify the relationships between these services that were drilled out from the event storming, which is handy, but also it helps us understand, do we have too many services? Are we thinking nano services now, this guy's not doing enough? Or do we have this huge hub and spoke where something maybe needs to be broken out? But what we found is interesting is it's actually a good exercise for people to just kind of play the what if game. If I'm thinking of making something event-based instead of, singular, sequential, how would this happen? Let's put a string from service A to service B and then just talk it through in front of a big whiteboard with twine on it. And it becomes very useful. It gives us the idea of how are we going forward into getting a start on our application. The other thing that this does is it will help us validate our slices. If we're thinking we want to do a slice of activity through this application, by going through this modeling effort interactively, you can get a really good idea about how things interact, and also cases where we've had customers who are sure, hey, we want to start our first service that we're going to migrate, or our first application is X, and we'll go through this model and realize, wow, that's dependent on a lot of other systems. Are we sure we want to start that way? And you don't have to do it by gut feel. It's just really easy to say, point to the whiteboard and say, this one has a lot of red rope on it. Is that what we want? So basically, the other piece then that we can do is a different color blue we're using for like sequential requests, REST calls, even socket-based calls to external systems, something like that. That is showing that service B may need to call service A through REST to fill out its information to be able to do its work, that sort of thing. You can also use different colors to identify different subsystems. So maybe what we came up with event storming, like you saw at Liberty Mutual, is there were tons of services, tons of interactions. Let's make this just a little bit smaller and walk through and see that this one's going to be very chatty. We need to think about building the service in a certain way. Or if you want to do the activity of saying, can we do something where you have services that are both synchronous and asynchronous? Or if we wanted to make a change to service B and then move it to a different location, let's just point it to a different queue. Does that work? So what it ends up looking like as we're going through this process is it looks similar to those 70s crochet owl things you'll see at garage sales. It starts out, but in the end, what ends up coming from this is you get something that is oddly organized. You'll have your UIs in the light blue that you could see where, hey, I may have an admin UI that gets deployed with this application, and for it to do its work, it has to touch these 3 services. Or in the upper left, as you can see, there's one service that talks to 3 queues. There's 3 subscribers, but you can see pretty easily that one broadcast out causes a flurry of parallel activity, and then it's sequenced in the end back in one message queue, which is kind of nice because you're composing futures with yarn and sticky notes, and you don't need to know the fancy words. It's just really, oh, okay, well, this is how our system is supposed to work. Now we just need to pick the technology to fit it. I like this method because it keeps you from thinking about, I really want to use Kafka for something. You know, it's more of, I really want my application to work or my system to work. And if Kafka is the solution, awesome. Here's how it'll work. If it's not, that's fine. We'll throw something else in the loop. So that's the next layer down from event storming. So now us technical folks can see a little bit more of the implementation, but we still need to go down a layer deeper. How do we pick which of these services to start working on first? Or how do we just learn more information about that? And so the next technique that we have is called a Snappy. And you may have heard of Snap Analysis. A Snappy stands for Snap, Not Analysis Paralysis, Enhanced. And Rohit is going to talk about the non-enhanced version, which is a little bit bigger a little bit later here. But basically what we're trying to do with the Snappy Analysis is say, based on those services, we know they're logical, domain-based services we want to build, they're going to have certain features, and they may inherit from the existing system that we're currently trying to modernize. They may be something that is brand new. It's kind of like your greenfield thinking about an existing application. And the things to me when I'm thinking about a microservice is, if I'm going to start writing this, I want to know things about like the API, for example. What flavors of APIs is this going to need? And you can look back at your Boris diagram and see, hey, there's these red threads and the blue threads talking to it. That means I need a RabbitMQ flavor and maybe a REST JSON flavor to start with. But I also have a little red sticky that tells me, oh, this needs to use CICS gateway for outbound traffic. So we're just kind of keeping track of that. We're also thinking about things like, for this microservice, do I have a data storage need, even caching? You know, I know that it needs to know about purchase history. It's our purchase service. There may be other data that it needs to store. We'll just document that. Again, we're not saying it's going to be in a certain technology. We just know it needs to be stored. If there's a UI associated with this, and for me, I think of this as not are there UIs that are hitting my API-based application, it's more of, for this deployment unit, is there a UI, like an admin UI, something that I can add purchase information or change rules, something like that. And of course, risks are important to document. If you have 500 red stickies on here saying this is dependent on all these unknowns, it may not be your first choice. But in the end, by walking through this exercise that takes, just a few minutes typically, you can start generating user stories. Hey, I know I've got these APIs. I know that through my thin slice that I'm thinking of, following the threads, I have this service that needs to talk to me here. I'll start putting some stories in about building out that API. And of course, building out the tests associated with that API. And in the end, what you get is something that looks more like this. Again, it's nothing fancy. They're just sticky notes on a big piece of paper. But typically, through an engagement, we'll keep these up on the wall. And because they're sticky notes and because the Boris diagram is fluid, you can move things around. You can add new strings. You can just document that through arts and crafts instead of trying to copy it onto a computer and then have nobody look at it again. So why are we doing a Boris? And first of all, this is a good point. This is Boris. Does anybody know why this guy is called Boris? Any guesses? Who? Right on. 2 thumbs up. So if you're a classic rock fan, The Who has a song called Boris the Spider. And that's why we call him Boris, because it's a spider diagram. I think they were under the influence when they sang that song, so don't hold that against us. But if you hear it, it's creepy and crawly. But we thought Boris is kind of cute. So for Boris, we want to use it to inform our architecture and document event flows, or even play the what-if game with event flows. We want to help convert context to a microservice. So the bounded context and the aggregates, let's map this out a little bit deeper and actually create microservices out of those. And also API discovery. You don't necessarily need to create APIs for everything up front, just the ones that are the touch points, just enough to get going again. Scenario modeling is nice because, again, that's that what-if game. Your VP will come and say, can you tell me what happens when I want to add a new service for validation? And you could say, oh, you just put it here and put these 2 strings, and it doesn't affect anybody else. And also orchestration to choreography. A lot of systems start out with orchestration, or you have a BPM engine, something that is pushing your state transitions. And using the Boris diagram and event storming, it makes it much easier to say, let's make things reactive. Let's have it choreograph. Things respond to events as opposed to pushing events, which makes it much easier to build and maintain. And then finally, you can validate slice candidates and fill your backlog. So for the slice candidates, this is the scenario where you're saying, I'm taking this collection of events, let's walk it through Boris and see if it kind of fits with what we want to do. Is add business value for this current MVP. And then, of course, we're looking to fill the backlog. We want to do some work. Let's not talk about it anymore. Let's get started. So for the slice analysis section of our wheel, Rohit's going to drill down a little bit deeper on that.
Okay. So let's start talking about slice analysis. So this is typically the second stage of your modernization. So first, you have gone ahead, you have done a big picture exploration, you have a complete map of stickies, you have orange stickies for domain events, you have aggregates, you have commands, you have tried to enforce a timeline on all these stickies, right? But how do you know which aspect of the system to modernize first? Right? So that's why you do an exercise known as the slice analysis, which starts with doing a big picture event storm, and then you gravitate towards the part of the event storm that has the maximum number of red stickies. Then what happens is all the people in the room do an exercise of dot voting and prioritize which of the red spots are the most important ones. And you now have a prioritized list of your top bottlenecks. That bottleneck, that's the top constraint, is you can also call it your core domain. If you follow the theory of constraints, it's the constraint that you need to exercise, it's the constraint that you need to solve for. So first you do the event storm, then you identify the bottleneck. After that, you go through a process of affinity mapping and dot mapping to figure out what is the core domain, which core domain to attack first, and then you go through a process of process modeling. So in that narrow domain, you then repeat this exercise of event storming. Like we said earlier, it's an iterative process. You can do it for the big picture, or you can do it for the smaller domain. Once you have identified the smaller subset of events, then you drill deeper into those events by then repeating the exercise and adding more layers of information. Essentially, the idea is starting from a large canvas, a big sky, a blue sky, and then drilling down to the more abstract, to the more specific. The outcome here is a set of stories that will modernize a set of microservices that are the most critical to your domain, that will solve your top constraint. That's the idea of picking the right vertical slice. So once you pick a vertical slice, right, you have an existing system that you're working with, correct? You have an existing application, a system, a module, or a system of systems. How do you take that and move it to the cloud, right? So step one of that is you have to look at the application and understand the characteristics of the application. So we do an exercise called SNAP. SNAP stands for Snap, Not Analysis, Paralysis. It's done in a time period of 30 minutes. The way we do it is we look at various characteristics of the application along various categories. What is the version of Java? Does this application have a CI pipeline? Does it have any monitoring associated with it? Does it use a lot of application server specific libraries? How difficult it is to take this application and make it into a complete self-contained application. The idea is we are trying to understand how much work it is going to take to make this application 12-factor or 15-factor or cloud native. This exercise of evaluating the application along these 30 different criteria, which are grouped in this picture here along colors, is known as snap analysis. What does snap analysis generate? It generates a backlog of items. How do we do this? We do the first one with the customer. We show them, first I do it, then we do it together as a group, then we ask customers to do it themselves. And I have customers here who have kind of followed the exact same pattern. So this is one of our earliest tools. Most of our app replatforming techniques, this was one of the earliest that came out. So how does this look like? We are a big fan of stickies, right? We definitely don't like PowerPoint at all. So you can see here, we first paint out the characteristics of the application, and then the characteristics of the application kind of drive the user stories. I'll give you a concrete example. If an application is configured with properties, then the correct thing to do to modernize it is to inject those properties as external variables. So we first replatform that, we first change that, and the next step is to then inject those environment variables through an external configuration server. So you can see the characteristic that configuration is within the application as properties led to 2 different user stories. The same thing then applies to all the other characteristics. We first take the characteristics, we map the characteristics based on the criteria that you saw on the earlier slide. We create the user stories. We define some metrics. What is important for end users for this app? What are the key service level indicators? What are the key service level objectives? What are the metrics that end users care about? And are there any risks for this app? Does it have any testing at all? Does it have an ant-based build? Do we have a dependency management system? Where does the code live? So it's an analysis of a complete application or a system or a module that is done in under 30 minutes, that generates the backlog and allows the team to get started and not spend a lot of time analyzing the portfolio. That's why it's done in a snap. So we've done this so many times. We created a web tool called Snap. The folks in my team have created a tool that you go in and provide your information and gives you a small, medium, large t-shirt sizing of Snap. Right now, this app is private, but we may in the future consider open sourcing it and releasing it to the public. So you might be wondering, where is the actual source code? I mean, we have talked about a lot of the techniques. So we are now at the point in our circle of transformation where we have a set of stories in a backlog to execute on. Okay? We have a set of stories. Now, with these sets of stories, what kind of implementation patterns do we use to implement these stories? So now I will go into a little bit of details of the techniques that we use, the patterns that we use at a code level to refactor our monoliths. So it's a bag of tools. It's a bag of patterns and recipes. The first one is when you carve out monoliths, or you have the big monolith and you have the smaller microservice. You need to be able to play with the traffic so as to direct only a small subset of the traffic to the newer microservice. Or you need to be able to change the monolith in such a way that you're not really exposing any features. In order to maintain stability of your monolith and carve out the microservice, you need to be able to hide features, right? So that's, or sometimes make sure that traffic is routed to only the monolith. So that's where these features like feature flags, dynamic routing, dark launching of features, these are the patterns that we use at the routing tier. Now, in some cases, in spite of doing all this analysis with event storming and Snap, we still don't have a good idea and understanding of the behavior of the application. In such cases, we actually start instrumenting the applications. We instrument the application with metrics. We wrap it with proxies, with aspects to understand the flow of data in the application, to understand the state changes. So there is a set of patterns to understand the current data flow and the behavior, and these proxy and wrapping patterns can also transform the logic and the data flowing in the application. So that's a second set of patterns called the decorator patterns. Now, another aspect of this transformation is the people aspect of it. In fact, if anything, it's the most important aspect of modernizing your monolith. Usually what happens is because of the high amount of entropy that has ensured, your application essentially becomes a big ball of mud. If any application that has lived for 10 years has suffered entropy and it becomes a big ball of mud. So you have to also apply the inverse Conway maneuver where you change the organizational structure of your company to the actual software architecture you want. This is the exact opposite of Conway's law. Conway's law states that software will take the form of the organization. In fact, you should do the reverse if you want to modernize systems, which is called the inverse Conway maneuver. You should organize your teams based on how you want your software to look like. Another set of patterns is the API gateway patterns, where traffic comes in on the front end side, and you may want to split it, you may want to route it, you may want to distribute it, and then fan out and fan back in. And so you use patterns like the edge server, backends for front ends, and the API gateway. But beware of the API gateway because it's quickly becoming the new ESB. If you start putting a lot of function into the API gateway, those things will start looking like your SOA ESBs of the past. A couple of techniques that have been inspired from the domain-driven design school. The most popular ones are the anti-corruption layer and the strangler patterns. The anti-corruption layer is very simple. You have a monolith that has a design, a structure, a flow, a logic flow. You are creating a new microservice that has a new domain model, a better software architecture, a different architectural style. It has the microservices style. You don't want the two worlds to mix together, right? So you create these anti-corruption layers whose job is to translate between the new world and the old world. They act as the buffers so that you can keep your models clean. And I'll get into some of this later as well. Another pattern is the strangler pattern, and I will get to that. We have more detailed slides later in the talk. Event shunting is a pattern where if you have an existing messaging-based system, all you do is take a shunt take that event from the older system and move it to the newer system. Think of like creating a copy of the event and moving it to the new system, and then you can extract what you want from the newer system and play with it. What other patterns do we use? We use patterns for abstraction, for routers, for proxies and facades. This is important because the most important thing when you are substituting newer microservices is you cannot have any disruption of the end user behavior. So the way this is done is you introduce an abstraction and have two modules or two systems or two apps implement the same abstraction or API. So that's where these behavior patterns like the proxy and the facade come into play. And the last one is there is a set of patterns where you are now going to a set of distributed services. Where you used to do orchestration, now there is no central orchestrator. So all of the microservices have to play together and have to realize an outcome, right? So you have to be eventually consistent. And there is a set of patterns around process managers and sagas that make sure that if you have long-running workflows, or if you have a workflow across various microservices, that those workflows still work correctly and the users get the output that they want. We also leverage patterns to destroy the ESB, right? We have a 5-step process to take an ESB and basically put it on a diet and extract all the microservices on it, and then put a choreography of those microservices with Spring Cloud streams in place. So these are the general universe of patterns that we implement in our code. So the strangler pattern, like I said, I'm not covering all the patterns here, but I'm covering only the noteworthy one. The picture that you see is the picture of, it's an actual real tree somewhere in Australia. And these creepers creep up from the top, and they completely encapsulate the tree, and then ultimately the tree itself dies. This is a real thing, and I Googled it, I'm sure it's real. So the idea is kind of similar, where you have a monolith, you have identified with all these processes and techniques the one area, the bounded context that you want to separate from the application, the first thing that you do is you put an API fence around it, which was that facade pattern that you saw. Once you have an API fence around it, that gives you the capability to now pull out that microservice, and so the monolith then talks to the microservice with APIs, and then eventually what can happen is that through these routing patterns, you can then route a set of traffic to the monolith, and then a smaller set of traffic to the microservice. Eventually, if you keep doing this again and again, that big monolith basically shrinks to 0. So that's the strangler pattern. This is a better pictorial depiction of the strangler pattern, and this is from a new book that just came out. I really recommend this one. It's called Cloud Foundry for developers. It's got very practical knowledge of how to use Cloud Foundry and develop with Cloud Foundry. Event shunting, like I said, this is used for modernizing existing messaging-based systems where you have a set of microservices talking to one another. What you do is you take some of the existing older events, you make copies of them and shunt them to a newer system and transform them with a newer set of microservices. So this is a pattern that was invented at an actual customer engagement. Anti-corruption layer. Like I explained earlier, these anti-corruption layers are essentially translators that translate from an existing monolith and to a newer bounded context. They are a combination of, usually an anti-corruption layer is not alone. It also has a translator and a facade and an adapter around it. The adapter, what does the adapter do? The adapter takes in the inbound traffic, be it through APIs or through messaging, and then the translator translates it to the older domain model, and then communicates it back to the monolithic application. So it's essentially a very sophisticated translator. That's the anti-corruption layer. This pattern is used a lot. The 3 patterns that you saw earlier, anti-corruption layer, strangler, and event shunting, are the ones that we use predominantly in most of our modernization engagements. So like we said, we have all these patterns. What do we do with this? We really care about these patterns that we mine, and so we create a cookbook, and then we leave this discipline with our customers, our partners, so that a curated set of recipes is born that they can then keep modernizing, they can keep building with. You can see that, like, this is our internal repository. Like, the most recent recipe was on 11/29. So the idea of showing this is that you should also try to create a body of work that can then be extended and used as other teams come on board. Finally, this is a shout out to the Spring ecosystem. We heavily leverage all the Spring stack, specifically Spring Boot, Spring Cloud Streams, Spring Data, Spring Integration. We use Spring to implement all of these patterns. So coming back to bringing the circle of transformation, completing the circle of transformation, Joe is going to finish up and conclude the rest of the talk.
All right, so thanks for listening. We'll just summarize some of the processes and tools that we went over. So this is our transformation circle. We started with OKRs. OKRs gives you direction and helps you stay on track. Event storming identifies business flows and identifies potential slices. Boris is used to document the event flow and inform the architecture, how you're going to start building your system. Slice analysis looks at small incremental pieces of functionality that we could put together to build larger systems. Snap and Snappy identify and measure in a very rapid fashion the size and risk of the subcomponents that we're trying to build. And finally, implementation patterns are repeatable processes that we store in a cookbook that we can reuse over and over and over again. And again, working around this circle of app transformation, we're always producing working code, we're always producing little slices of incremental functionality, and we're always producing repeatable patterns. And we rinse and repeat. This is not a waterfall process. We do these as many times as we need them in any order in which we need them. And obviously, hopefully that this turns our scary dragons into our happy dragons. Thank you very much.
take time for questions. Anybody have any questions?
What's dot now? Dot voting.
Dot voting is very simple. Essentially, when you have a set of things that you want to drive consensus on, you give everyone in the group basically 3 dots, and they have to take those 3 dots and put them on any of the 3 on the red stickies. The red sticky that gets the maximum number of dots, that's the highest priority item that you need to look at. It's a group exercise of figuring out what is the highest priority item across a whole swath of stickies or across a whole swath of items. Right. So, I mean, so we didn't get into how we actually, how we execute, but the first thing that we do is whenever we touch a piece of code, we write tests around it. So typically when we do replatforming or modernization, we write smoke tests, we introduce Spring Boot actuators. If there are existing test harnesses that are disabled, we try to figure out why they are disabled, and if possible, we enable them and add them to the CI pipeline. Within reason, we practice TDD and we try to increase the test coverage where possible. Most of our changes are not non-intrusive for replatforming, and for modernization, where we are completely carving out microservices, there, we oftentimes write newer test suites, functional suites, to test functionality. But in replatforming, it's mostly making sure that we haven't changed or altered existing function.
Any other questions? So who was it that got the Boris right? So I'm happy to hear that, because we were worried that we had to start naming things from something that was derived from this century. So it's comforting to know that we're not the only ones that remember back past the previous century. So.
All right, thank you very much again.